Hello everyone, hope you are all doing very fine. And my name is Ram Murla. You can find me on LinkedIn. You can search with Ram Murla. And if you happen to see this slide set, you can actually click my name and it will lead you to LinkedIn. Do send me connect requests or ask me any questions. Do follow me. I want to discuss today about predictive analytics. So what is predictive analytics? For example, I want to today I want to explain about the house buying process. I want to go and buy a house in a neighborhood. So in a neighborhood, I'm not the only person who would be buying the houses. There are hundreds of people who already bought the houses and hundreds of other people who wants to buy the houses. So, and everybody goes there. They won't buy the houses just like that, whatever cost that is quoted by the builder or a seller or real estate agent. So they do a lot of research. So to do a lot of research, they will have to collect the data. So the project is buying a house. They need to collect the data, they need to analyze the data, they need to apply certain statistical principles such as regression, uh, and then pass this regression statistics, the statistical principles through a number of stages and then reap the benefits. Basically, builder tells you that your house costs 100,000 and you will negotiate between 85,000 to 95,000 based on the data you have collected and based on the intelligence you have gathered using the regression statistical principles. So different kinds of data, right? So you collect the data from various areas, as websites, CRM, customer relationship management data, data collected from the purchase section, land registry, etc. And social data, people will be discussing about on the house purchasing prices and selling prices on social media, etc. And third-party data, mobile data, and so many other things, right? And for each kind of data, you need to apply certain strategies. For example, if you want to collect CRM data, it's just not possible to collect the CRM data just like that. You need to prove, you need to follow a particular strategy. So I have listed down 3 different kinds of strategies here, but doesn't matter. It could be one strategy, 5 strategies, 55 strategies, 75 strategies, or whatever it is, just a number. Okay. So for each kind of business, you have a different kind of strategy. And for each kind of business, then you have each kind of data, you have different kind of strategies. So next slide. So once you collect the data, you analyze the data. But to analyze the data, you need to identify the quality of the data. So is the data clean? The data has missing values. If the data has missing values, what should you do? If the data has impurities, what should you do? How do you deal with that and all these kind of things? There are several techniques to deal with this, so we will discuss about these things in different kinds of sessions. But right now we need to clean the data, we need to supply the missing values and explore and visualize data, tabulate the data and build models like such as apply the models called such as regression, and then predict and then validate the results and reap the benefits. So for example, let's discuss about regression. A lot of trainers unfortunately teach you for hours on regression because they don't know how to teach you. Simple, regression is about prediction. Please note that none of the prediction methodologies will give you exact 100% accurate results. So to learn about prediction, you need to understand about 2 important aspects of the data. So data is all made up of variables. Let's say, for example, you must have heard, I mean, you're all IT professionals, you know X, you must have studied mathematics while you're doing your 10th class, intermediate, plus 2, etc., or graduation, etc. So X and Y. Okay, so these variables, right? A, B, C, D, A square plus B square plus 2AB is equal to A plus B whole square. So A and B are variables, right? So there are two different kinds of variables here. One kind of variable is called dependent variable. The other kind of variable is called the independent variable. Okay, dependent variables are always defined if it is x and y. Defined dependent variables such as in this example, buying a house, the total cost of the house is the dependent variable. And the value of uh, uh, per square feet, let us say for example, is the independent variable. And you will see what does it mean, right? And if you go to the next slide, right? So let's build a model. This is a regression model. So how do the regression model works? So for every house you want to buy, there is a basic price. The basic price is dependent on the cost of the site the house is built on, right? Because they can't sell less than that. So nobody can sell a house for 25,000 pounds if the cost of the site is 45,000 pounds. So most houses, let us say in that neighborhood, might sell around 45,000 pounds. So that's the basic minimum. Plus, they also need to add 75 pounds per square feet of the area of the house. So the house might have 2000 square feet, 1200 square feet, 1000 square feet, 200 square feet, 15,000 square feet, 30,000 square feet, depending on the size of the house. And as the size increases, the house cost increases, right? Because the formula that what we have used here is house cost is equal to 45,000, which is the basic price, plus 75 multiplied by the size of the square footage, right? But that doesn't work like that. Every time, for example, you go to buy the house and I go to buy the same house, the house owner who is selling the house might like me and might like you better than me. So she might give you 20% discount on the construction cost, and she might give only 15% discount to me, depending on the interest that you and I show, or various other parameters, right? So that parameter is called the error. So that's the error, right? That's the error. Now, it's not only you and I, there are hundreds of people who wants to buy the houses, right? So each dot here relates to one house being sold. So at this cost, these four houses have been sold. At this cost, these four houses have been sold. This cost, these many houses have been sold. This cost, these many houses have been sold. So on an average, if you draw a line from the middle, this red line states the average cost of the house per square feet, right? Since the cost of this behave unpredictable, we add a random component called error. This is the error, right? So look at the formula. The formula looks very complicated, but it's simple. Beta 0 is the basic cost of the house, basic cost of the plot. Beta 1 is the cost of the square foot multiplied by the square footage. Error is the error added, discount or premium that has been added. Okay, so why do we need to do predictive analytics? We need to do the predictive analytics to increase the operational efficiencies, increase customer service, increase profitability, new revenue opportunities, achieve competitive advantage. Thank you. I live in Milton Keynes, and my contact number is +44 1908 766 239. You can actually send me a WhatsApp message on this, asking questions about this particular slide set, or you can also email me at ram@xpin.com. Thank you very much. Have a great day. Hope I could clearly teach this. If you have any questions, please do not hesitate to contact me.